solids of revolution. Objectives. By the end of this lesson, you should be able to identify the region being rotated, ensure the axis of rotation is a horizontal line y equals a, find the limits of integration, and set up the integral with respect to the x needed to find the volume. So what we're doing this lesson is we're finding volumes now. Now here's the good thing about IB. We're going to do it very basically. We're just going to do it one type of way. And that is really, right, so what we're doing is this. We're going to find the area underneath the curve. Hey, that's integration. Right, so we're going to find the area underneath the curve. And what we're going to do is we're going to spin it around. Right, so you spin it around and you get something like this. Right, so how do you do that? Well, you kind of spin in a circle. So what we're going to do is we're going to find area of a circle, pi r squared. Right, see how this is a circle right here? Right, if I was going to spin this around, I would make a little circle on the back end, which is basically this right there. Right, so it'll be pi r squared. Well, how do you find the r? Well, r is the radius. And what's that radius? It's the area. It's all this area. How do we find area? We integrate. So we're going to integrate. Now that isn't r. What is r? Our equation. That's where this formula comes from. Right, that's all we do. If I want you to find volume, this is in your formula sheet by the way, you just do this. You find your equation, you square it, and you integrate it, and then times it by pi. Right, it's based on area function, area of a circle function, just with the integral attached. That's all it is. So it's this formula. Key thing is this is your equation. You square it, and you times it by pi. So it's actually very similar to the area equation. What's the difference? You square it and you times it by pi. So that's how you find a volume. It's super basic, right? Just keep that formula in mind. It's in your formula sheet. All you gotta do is find the equation, square it, integrate it, and then times it by pi at the end. That's how you find volume. So let's do an example. So we're going to use integration to find the volume when we rotate y equals x around the x-axis from 1 to 4. So only that spot there. So that picture they give you, right? So we're going to, this little area there, we're going to spin around. So if I see the words volume, I look at my formula sheet and I go, oh, it's this thing. It's pi that square of my equation squared, right? A to b. So let's find that. Well, we're going from 1 to 4, so that's my a to b. Right, I have pi. What's my equation? Well, it's this thing, y equals x. So here's my formula. Pi 1 to 4 of x squared dx. Right, now, I still got to integrate this. So we're going to integrate it. Basic power rule. Add 1 to the power, divide by new power. Love the power rule. So we're going to get x cubed over 3. Now keep in mind we have limits, so there's no plus c in this case. Now we have the little from 1 to 4. Remember the way we do that? Top minus bottom. So you can either multiply pi first or keep it on the outside. I'm going to keep it on the outside. So pi times 4 cubed over 3 minus 1 cubed over 3. So it's going to be pi times 64 over 3 minus 1 over 3. So it's going to be 63 over 3 pi. And that's the volume of that thing when you rotate it around. Right? That's all it is. Put in the formula, plug it in. Let's do another one. Find the volume of the solid. Find the volume. Again, I see volume. I think formula sheet, pi y squared. Right? It's in your formula sheet. A solid formula when the graph of the function y equals x squared for 0 to 5 is revolved around through 2 pi. So again, that's just all fancy way of saying find the volume. We know how to find volume. We have the formula. We just got to find the limit. Hey, they're right here, 0 to 5. And there's my equation. So let's plug it in. 0 to 5. Now again, my equation is x squared. I still got to square it because it's the equation squared, dx. So I'm going pi 0 to 5 of x to the 4th dx. Now we integrate it. So we're going to add 1 to the power, divide by new power. So I'm going to get pi times x to the 5th over 5. Now again, we have limits, so 0 to 5. And then we plug top minus bottom, so pi times 5 to the 5th over 5 minus 0 to the 5th over 5. So I'm going to get here 5 to the 5th is over 1. I'm going to get pi times 5 to the 4th. I don't know what 5 to the 4th is, but whatever that is. Right, this is a 0. I got 5 to the 5th over 5 to the 1st, so 5 to the 4th. But again, that's the general idea. If I want volume, I just do that. Just use the formula, right? It's basically area formula squared times pi. And it's in your formula sheet. Let's do another one. So look at this one. Again, notice it says volume, so I'm just putting the formula right away. Just thinking of the limits also. Easy. Remember, the formula is the thing squared. Seeing this looks ugly, I'm squaring it, right? It's pi, the thing squared. That squared and the square root cancel out, and I just get pi 0 to 5 of 25 minus x squared dx. Keep in mind, I still haven't integrated yet. I just did some basic algebra, so now I'm going to integrate it. Remember, that's the power rule, so add an x there, because it's a constant. Here, add 1 divided by any power. So minus x cubed over 3. Again, the pi's on the outside, and we're doing limits from 0 to 5. And again, that's just like arithmetic. Plug in 5, plug in 0, subtract, get your answer. I care more about the idea though, right? That's how the idea how to do it. We can also do this with the calculator. Use technology to correct the 3 sig figs. Again, it's volume, so all we're going to do is plug this in our calculator. So in our calculator, you're going to plug in 0 to 2. You plug in pi on the outside times sine x, and then whole thing squared. Plug it into your calculator, and you get 9.613 times pi, and then times it by pi yet, and then if you times it by pi, you get 30.1989, or 30.36 figs, so 30.2. Right, straight out, just put in your calculator, the exact same way you'd normally do it. So let's go on to what we want to find volumes between two curves. So let's look at this one here, right? So we're going to get that little spot and we're going to spin it around. So you get something like that. Well, it's just like doing area between two curves. The exact same idea, right? We're going to do top function minus the bottom function. Now, since this volume, we're going to square it. And then we're going to times it by pi. But other than that, it's the exact same concept, right? Just like you did area between two curves, top minus bottom. Now we're doing a volume, so the only difference is you square your functions and you times it by pi. Only difference. It's the exact same concept. So let's do a couple examples before we head out of here. So this first one here. Find the volume of the revolution generated by rotating the region y equals x squared and y equals absolute value of x about the x-axis. So we're going to spin it this way. So it's the same idea. We're going to integrate it. Times it by pi because we're doing volume. My limits, it looks like we're going from 0 to 1. They helped us out. Remember, if they didn't give us the intersection point, we got to find it ourselves. Just set them equal to each other. Now the top equation is this one. So square root of x minus the bottom equation, which is this one, x squared. Don't forget we're doing volume, so we got to square them afterwards. Right, so just set it up. Top squared minus bottom squared. So we can simplify that a bit. This is going to be x minus x to the 4th dx. Right, just doing some basic algebra. Now, integrate it. So, super basic, power rule. Add 1 to the power divided by new power. Add 1 to the power divided by new power. So we're going to get pi times x squared over 2 minus x to the 5th over 5. Now again, it's a definite integral, so from 0 to 1. Now plug it all in, and you're going to get, looks like pi times 1/2 minus 1/5. And then whatever that turns out to be. Common denominator, 10, 5, 2, 3/5, 3/10 pi, if you do it correctly. Right, but this is that. I care more about the idea. The rest of it's just arithmetic, right? The idea is top minus bottom, just like you do area. Top equation minus bottom equation, but then attribute the velocity. Well, sorry, the volume ideas to it. Square it and then times it by pi. So let's do one more or two more. Sorry. This next one, same idea, right? We want to rotate this region around. So first thing we gotta do is find where they intersect. Right, because it looks like my integral is gonna go from 0 to a, which I know what a is yet. So let's find the intersection first. So remember when we do that, you set them equal to each other. So e x over 2 equals e to the first. Goes like that. Take a natural log of both sides, you get x over 2 equals 1, times it by 2, x equals 2. So that's at 2. Now find the volume revolution. So remember again, we're going to do top minus bottom. The top one is this one. So that's e. Then we have to square it. Almost forgot about the pi. Minus the bottom one, which is this one. So e to the x over 2 squared dx. So to simplify before we actually take the integral, so it's be pi 0 to 2 e squared minus e to the x dx. Now we can integrate this. Now again, this is just a constant. There's no x there. So that's all you have to do is add an x there. So e squared times x. Now remember over here we're integrating e. Integral of e is this e. Again, we're doing limits. So we're going to go from 0 to 2. So now we just plug that in. It's going to be pi times, plug 2 in, 2e squared minus e squared minus parentheses e to the e squared times 0 minus e to the 0. Now watch out. 2e squared minus 1e squared is just e squared. Over here, that's 0. That's not 0, that's a 1. So here's negative 1. And it's getting a little messy. I always should give myself more space. So I get pi times e squared plus 1. And that looks like the answer. Right, I got a little messy there, but the general idea is I just simplified it, plugged in 2 to everything. So 2e squared minus e squared. So I could reduce that and just get e squared. I plugged in 0 to everything. That just goes away. This doesn't go away. It's e to the 0, which is 1. Very important, right? That doesn't go away. E to the 0 is 1. So then it was negative, negative 1, so plus 1. So I got that. And let's do one last one. Last one for integration. Calculate the volume of a solid obtained by rotating the region by y equals x and y equals 4 minus x about the x-axis. So for this one, right? So again, notice I don't have anything. We have to graph it ourselves. So y equals x looks like this, right? It always helps if you actually do y equals x plus 0. So you start at 0 and go up 1 over 1. So something like that. And the next one, y equals 4 minus x, so go up 4. And down 1 over 1. So something like this. And we probably want the region bounded by y equals x and the x-axis. So we want this region. Right, so this is 4 minus x. So there's a lot of stuff I already know about my integration. My integration is going to be pi, because we're doing volume. It looks like we're starting at 0. Now top one is the blue one here, so 4 minus x squared minus the bottom, which is x, and then squared dx. I don't know where they cross yet, so I gotta do that. Remember, the way you always find the intersections is set them equal to each other. We get 4 minus x equals x. Do a little math. Add x. 4 equals 2x. X equals 2. So they cross at 2. Right, and then from there on, we just simplify it. Now again, if you use a calculator, which is honestly most of the time with one of these, they'll let you use a calculator. You just plug in your calculator. They're not really big on making you do busy work. Otherwise, you actually expand this out. Don't just square everything. I hate that. Remember, the plus or minus in between, you expand it out. And you're going to get 16 minus 8x plus x squared minus x squared. Hey, these cancel out. And you just get pi times the integral 0 to 2 of 16 minus 8x dx. And that's easy enough to solve. We could do this. Let's finish on a strong note. So we integrate this, add x to both, add x there. This is a power rule. So we're going to get 16x minus 4x squared from 0 to 2. all times pi. Right, then from here, as we always do, plug the top one in minus plugging the bottom one in. So it's going to be pi times 16 times 2 minus 4 times 2 squared minus plug 0 in for everything. In this case, that's going to be 0. So that's just gone 0. So I'm going to get 32. Do this first. That's 4. 4 times 4 is 16. So 16 pi. Right, and that's how you find the area in between two curves. Or sorry, that's how you find volume. Right, so volume very similar to area. The difference is there's a different formula, right? You square it and times it by pi to find the volume. But other than that, you just treat it the same way, right? This is the volume. This is the formula for volume. You treat it the same way. Get your function, get your limits, plug it in, right? Since it's a volume, we're going to times it by pi and we're going to square it. But other than that, you're just doing calculus. It's doing basic calculus. If I want the volume between two things, just like we do area, top minus bottom. So if you don't have the picture, draw the picture, draw a very crude sketch of the picture. If you don't have the intersection points, find the intersection points, send them to each other. But other than that, it's top minus bottom. What's the difference? Since it's volume, you square them and you times it by pi. And that's it. Progresso out.